Hello, my amazing students. This is Mrs. A, and I love math. And today we're on lesson 96, which is the difference of two squares theorem. And we're going to be learning a theorem that you're going to use over and over and over for the rest of your life. So make sure you get it, okay? So let's just recall that 2 times 2 is 4. That's pretty easy, right? But also, -2 times -2 is also equal to 4. So when it comes to square roots, which is going backwards, 4 has 2 square roots. Positive and -2 are both square roots of 4 because both numbers, when squared, gives you 4. However, we have a special notation, this square root symbol. When we see the square root symbol, it means the principal of the 2 square roots, which is the +2. If we want to indicate the negative square root, we write negative the square root of 4, which tells us to use the negative of the 2 square roots. Now, let's consider the problem. X squared is equal to 4. And we must consider both positive and negative square roots. Now, x squared is equal to 4 is of a form p squared is equal to q squared. Okay? And if we were to get the q squared on the other side, we'd get p squared minus q squared equals 0. If we were to factor that, we would get p plus q times p minus q is 0. All right, so we're developing this theorem here. So let me let you see that, and then we'll erase the board and move on so that you can see the theory behind this theorem. So continuing on, let's recap. We have p squared is equal to q squared. And that means that p squared minus q squared, we're just moving this over with a minus sign. We're subtracting q squared from both sides. P squared minus q squared is 0. We factor this difference of 2 squares into p plus q, p minus q, and we get 0. Since they're both, the product is set equal to 0, that means that we use the 0 factor property, which we set this one equal to 0 and that one equal to 0. And we get p is equal to negative q and p is equal to q. Therefore, we have m squared is 9 is going to yield m is plus or minus 3. We're going to get 2 of them when we see it in this form. However, if we see just square root of 9 with a radical, then we would use just the 3, not the plus and minus 3. That's very important to remember. Okay, so here's our first example. We have p squared is equal to 16. Okay, well, this is of the form p squared equals q squared. And we've already talked about the answer to this is p is q or p is negative q. 2 answers. Therefore, p is going to be 4 and also -4. So we often write that p is plus or minus 4. And that would be the solution because this is written in that form. There is no radical sign. So here we have another one. This one's not quite as pretty because we don't have a perfect square over here. But we know that we can still write it p is plus or minus the square root of 41. Even though that isn't a perfect square root, this isn't a perfect square, we can still write, okay, the square root of 41 plus and minus because there are 2 answers. Negative square root of 41 squared would give you a positive 41. And positive square root of 41 squared is going to give you a positive 41. Okay, so here is our last example and our first practice. This was a very short lesson. Okay, so k squared is 13. We're going to realize that square root of 13 squared will give us k. Also will give us is k. K is plus or minus square root of 13. All right, and this one, it says in our practice to actually use the difference of 2 squares theorem to show how we get this solution. So what we're going to do is we're going to say this is p squared equal to q squared, okay, which is going to lead to p squared minus q squared is equal to 0. Now we're going to go ahead and put the q squared into this. So p squared minus 169 is equal to 0. Okay, now we're going to factor this. P plus 13, P minus 13 is equal to 0. Then with our 0 factor property, we set each one of these equal to 0. P plus 13 equals 0. P minus 13 equals 0. P equals, subtract 13 from both sides, add 13 to both sides. And we get P is plus and minus 13. See if I can get the glare off of there. Again, our instruction is to use that difference of two squares theorem. So we're going to make this one into a p squared, and that is going to end up being square root of 23. The p is going to be the square root of 23, isn't it? So we're going to factor this into q squared minus 23 equals 0. That will be our first step. And then factoring this is going to be q plus the square root of 23, q minus the square root of 23 equals 0, factoring a difference. So even if it's not a perfect square, we know that this one square rooted is square root of 23, and then we use the plus and the minus. We set this one equal to 0, and we get q is negative square root of 23. We set this one equal to 0, and we get q is positive square root of 23. So we have the two answers, and that's using your square root difference of two squares property. Okay, so now, last practice. Hopefully you can do this by yourself. We're going to start by writing it as w squared minus 14 equals 0. We're going to factor that into w plus the square root of 14, w minus the square root of 14 equals 0. Since their product equals 0, then we set this one equal to 0, w plus square root of 14 equals 0. We set this one equal to 0, w minus square root of 14 equals 0. We set this one equal to 0, and we solve, and we get w equals a negative square root of 14. And then from this one, we get the positive square root of 14. W is equal to plus or minus the square root of 14. So, your book wants you to be able to explain that process. We are done with lesson 96, and that was all there was to it. This is Mrs. A, and may God bless your day.